Charan, are you there?
Yeah, hey Ganesh, Sharan here. So I'm working as an SME subject matter expert, which is a different process, not related to IT. Basically, it's a non-IT. So I just wanted to switch my career to IT. So, so I've been working for 3 years. So now this is IT is a new career for me. So I'm looking for a good kickstart. That's it. Thank you.
Thank you. And Devakar?
So I have 3 years of experience in a QA, like in manual functional ETL testing.
Okay. And Shreya Tripathi?
Yeah, hi Ganesh. Hi everyone. Currently I'm working in TCS and I have like 3 years of experience. Like currently my project is related to data engineering only. So I'm looking to upskill myself in AWS.
Okay, thank you. And I can see one person, Motorola Edge 30 Fusion something. Can you just rename yourself and also can you brief about yourself? We are not able to hear you.
Hello.
Yeah, hi.
Yeah, hello everyone. Actually, I joined this session from mobile, so I'm not able to edit this. So I recently joined one company as a data engineer. I have basic knowledge of PySpark and Hive technology, but here I have to work purely on AWS as well as on real-time data. So I just want to enhance my knowledge in cloud and in real world data.
Okay, thank you. And
Yeah, thank you.
Suresh?
Yeah, hi Ganesh. Even I'm working in non-relevant to IT only. I have just 1 year of experience. Trying to shift to AWS data engineer.
Okay, Suresh. Thank you. And Vinay?
Yeah. Hi, Ganesh. Hi, everyone. This is Vinay from Hyderabad. I have 2 years of experience as a data analyst in ADP. Here, I joined in this course in order to get more about the data cloud engineer to upgrade my skills.
Okay, thank you. And Sugmar? Sugmar, can you brief about yourself? Okay. Ravi? Ravi, can you brief about yourself? Yeah, sure. Ajur, can you brief about yourself?
Yeah, I've been working as a Teradata database administrator from last 2 years. I'm looking forward to switch as AWS database data engineer.
Okay, thank you. Yeah, Aditya, you can go ahead.
Thanks, Ganesh. Hey, everyone. Good evening, good morning. Thanks for joining. My name is Aditya. I'm by profession is a data engineer, ML engineer. Uh, my core interest lies with the new tech emerging inside the space itself. I work for a Fortune 100 company. I'm having close to 9 years of experience purely into the data itself. I started my career as a basic data analyst, I would say, and then gradually move into the AWS side of things, cloud, PySpark, big data, right? And today, if I have to say, we are utilizing Gen AI to do a lot of data engineering and machine learning and analytics itself. That's a bit about me. I have passion of learning what new is coming in industry with respect to data, and then turning this passion into a greater advantage and then sharing whatever I know in simpler, easy to understand, easy to digest topics. This is the kind of feedbacks we are getting from a lot of previous batches that we have conducted, and with the same intent, I want to improve more and more and more, give better lessons out, give better topics, and yeah, so that's a bit about me. Having said that, so as we all know why we are here, because there are two terms which are very catchy. One is AWS, and the second term is a combination which is data engineering. These are the two buzzwords, right? So let's break these buzzwords. What these buzzwords means, right? Let me share my screen. Okay. Just can anyone confirm if you're able to see my screen?
Yeah.
Thanks for the confirmation, right? AWS data engineer. Right? Let's go understand what exactly AWS data engineering is, right? But before we actually, deep dive in data engineering, I want all of us to travel back in time, maybe 30 years. So at the age of beginning of computer era, right? So computer was born nearly about 1980 on a mass scale where it is started getting utilized by industries. Industries like NASA was one of the early adopters of using computers, and then other industries, Coke, Pepsi, all of these industry started to use computer. But why? What advantage computer was bringing at that time, right? So NASA was launching their rockets, and they have to do a lot of calculations, right? And you can understand how space calculations are, or is basically, right, how tough they are. So they have to hire statisticians, mathematicians. They were doing the calculation roughly, orally, right, or using pen and pencils. When computer was launched, they were able to build a calculator, and because of which the speed by which they were able to perform calculations has multiplied by 100x. They were able to ship the calculation 100x times faster by the introduction of calculator. And this calculator was running on a COBOL system. And this computer, if I just have to give you a perspective, it is kind of a very big room. So that's the size of the computer at that time, and it was able to store 16 bytes of data, right? So you can imagine the starter journey of computer, and that's where the computer was introduced to us, and everyone saw the benefits of computer. Things were speed up, and people started gradually shifting towards the use of computer, and they started using it for various purpose. Few years fast forward, computer now become the household in America industry, where they were maintaining inventories on top of the computer, where they were maintaining the ledger. People were documenting how many orders they are doing throughout the day through the store itself, and they were maintaining all of this information on the computer. As the data grows, as the sales grows, the number of orders they are making, the number of inventory the companies have become many folds. Now, storing this information into a simple computer with no software over there was getting difficult. Then Microsoft, cracked a amazing brilliant idea in 1990s, give and take. And that amazing idea was MS Excel at that time. I don't know how many of you know the history of MS Excel, but if at that time somebody put that they know MS Excel in their resume, they were hired crazy. They were getting the above market standard salaries. They were the god of their time in this space of computer engineering, if they know how to operate Excels, right? So what they were doing in Excels, they were maintaining data, doing data entry, managing inventory, calculating the number of orders, understanding how many orders they may need tomorrow by looking at the number of orders today, right? So they were doing a lot of data engineering in 90s 90, but using Excels. Why? Because the data was not that big that we have today, and that was the only tool, and the computer has little amount of RAM and everything. So Excel was one of the best solution out there. But few years down the line, Excel was started cribbling. Why? Because the limitation with Excel is you can only process 10 lakh records. If you want to process more than that, Excel may not be the right tool, right? And therefore, then it make the born of databases. Then in databases, people can store more data and they can do n number of things now after putting the data into a table, into a database, right? But the question is, how do we load the data into a database, right? So to load the data into a database, people were using MS Access at that time, or through manually they were loading it through scripting. So there was a lot of gap of how you actually load data into a database itself. And at that time, a lot of ETL companies were born, a lot of ETL tools were born. I would say data engineering was evolving in the era of 2000 to 2010. And at that time, few popular tools like Informatica, Cognos, um, then IBM tools, and bunch of other tools like Alteryx. All of these tools were born. The sole responsibility or the actual work of these tools is to pull data from some source. It could be a file, it could be a table, do some bit of changes in the data, and then finally load it back to a database itself. That was the responsibility of these tools, and this is what data engineering at that time is. So when these tools hit the market, and if somebody knows these tools, then these people become the god at that time, and they were hired crazy, they were paid crazy at that time, right? So if you see the shift, 10 years before, Excel was the king, people know Excel, they were hired crazy. 10 years down the line, these tools were kind of king, and then if people know these tools, they were hired crazy, right? Then down the line, few years more, the volume of data further increases, and it poses a lot of challenges in how you manage and maintain this data. So these tools started taking a toll. They were not able to perform well, and therefore data engineering further evolved. So few new age technologies like Hadoop, Spark, PySpark came in the market. So if I fast forward from the year 2010, and if I say till 2020 or even today as well, if somebody knows I am a big data engineer, I know Spark, Hadoop, then that person become god at the time, and he was hired crazy, people were paying a lot of money, right? Because that was the most cutting edge or emerging technology, right? Now if I again fast forward today in 2025, what things still stand tall is data engineering, right? No matter what, if you're using Excel, no matter what, if you are using Informatica or other tools, no matter what, if you are using Hadoop, Spark, PySpark, or today Gen AI or AWS or whatever, what one thing which stands tall till now is data engineering, the concept of data engineering, and the concept of ETL. ETL stand for extract, transform, and load. And guys, this is the core essence of data engineering today, right? Just to give you a few numbers quickly. So we all know how Instagram, Facebook, WhatsApp actually impact our decision making, right? There was a study which was published last year, and as per the study, 25% of the orders that we do today is directly or indirectly derived through Instagram slash Facebook slash WhatsApp, right? I'll again quote it, 25%, even more than that, right? The orders that we are making today either could be offline or online, is basically influenced because of WhatsApp, Instagram, and Facebook, right? So these companies utilize our data whatever data we generate in the form of comments, photos, video, whatever we are doing over the internet, they utilize this information, try to influence our decisions, and in turns, they make loads and loads of money for themselves or for the businesses who are using these social media platforms to increase their revenue, right? Now, how all of this is happening, right? How the Facebook, Instagram, or whatever these companies are, how they're able to influence our decisions. So what they're utilizing is the data that we generate, and they're purposing this data so that the business can use it and make meaningful insights out of it. So how they do it? So the process of doing this raw data into a meaningful insight, guys, is called data engineering itself, right? I'll give you one more example, which is a very practical example, which most of the people may know, right? There are two new companies which are startups in India, I would say. There's a company with the name called Park Plus, and there is a company called Mygate. These are two companies which are very popular in tier 1 and tier 2 cities. What Park Plus does is, so they basically install the boom barriers in high-rise buildings. So basically, if you have their app and if you want to enter the society, right, your resident complex, by default the boom barrier will scan the code from your vehicle, from your car, and then automatically you can enter and exit from the society. And you can get notifications, okay, what time your car is going out, what time your car is going in, right? They're providing this service free of cost today. No money is charged from their side, right? But they're not Robinhood. They are not, company who had loads of money, to provide us services for free. So how they are doing it? What is making them provide these services free of cost to us, right? So what they're doing eventually is building a customer profile for us, right? By knowing what time I enter my society, knowing what time I exit my society, they can track whether I am a morning person, whether I am a evening person, whether I am a night person, right? And they can then sell this information to lot of companies who need this kind of data, right? I'll give you one more similar example. There's a company called Mygate, right? So again, it's very similar. They are targeting tier 1, tier 2 city. What they do, if any person wants to come inside your society, it could be a courier, it could be Zomato, it could be Swiggy, it could be any guest. Basically, they need to take the approval from the resident, right? Through an app itself again. So if somebody approval come to you, you have to approve, and then that person can reach to your apartment. Again, they are providing this service free of cost, no money is charged. But why they are doing it, right? Again, they are building a customer profile. What kind of a profile, right? So if they know this person is ordering biryani through Zomato at 2 a.m., right? So a Zomato rider will come in. He or she has to take an approval, and that approval is getting tracked. Okay, for this customer, most of the time, he's ordering from Zomato during the window of 2 a.m., midnight, 3 a.m., midnight, or 1 a.m., midnight. So they know this person is kind of a night person. And now MyGate can sell this information to a competitor. It could be Swiggy, right? They will say, Swiggy, hey, this customer would like to order most of the time between this 1 to 3 a.m. window. He prefer this kind of food, right? So you can utilize this information. So what Swiggy will do? Swiggy, around 12:30 a.m. or 1 a.m. in the morning, give a pop-up to the customer saying, hey, you may like the biryani. We are providing you 30% discount, right? So definitely, right? You are a biryani person. You would like to order around this time, but here on a different platform, you're getting a 30% discount. So most likely you will try to switch and you will order from there, right? So that's how this information is getting utilized to generate more business for these new age companies, and we are knowingly unknowingly lefting our digital footprint, which is utilized for building money for these companies itself. And how all of this is happening, it is happening by utilizing the data And how do we utilize this data? By doing data engineering on top of the data that we are building, right? And who does the data engineering? So the person who does the data engineering is called data engineer, right? So this is what data engineering is. This is what a data engineer is all about, right? Now coming back to this quick slide, what data engineering is all about. It's building scalable, maintainable infrastructure slash pipelines slash ETLs slash data storage itself, right? What ETL is? ETL means extract, transform, and load. What infrastructure is? Infrastructure is a solution which help us run the ETL itself. So what data engineering is all about? Building such infrastructure which help us do ETL, that help us drive key information out of the data so that the business can take informative decisions which eventually help them make more money itself, right? What are the key responsibility of a data engineer is? To collect data, to analyze the data, to build ETL pipelines, right? Load this data back to a data storage and to data warehouses, right? These are the major key responsibility of a data engineer is. Why it is important? It helps us take more informed decisions. The business, basically, right? So if let's suppose Walmart, right? Everyone knows Walmart is. It's one of the US retail chain is. So if let's suppose Walmart wants to open a new store, which locality they will open, which city they will open, how do they decide? So basically, they go back in the past, scans all of their different stores data, then understand, okay, in which city, what kind of location a store becomes profitable, and accordingly, with a similar set of parameters, they came up with a new store in the new locality, right? Then everything cannot be so easy in data engineering, right? There would be a lot of challenges. So, what challenges data engineers or data engineering has today, right? One of the major challenges scalability. What scalability means, right? Let's say we built a system that is very good to handle 10 lakh records. We built using Excel, but then as the data grows over the period of time, the system can no longer handle more records, right? Which means we need to move to a better system, right? So in data engineering, we cannot just keep on jumping from one system to another in real world, right? It needs a lot of money, lot of efforts, lot of manpowers. So what we suggest that build a scalable system. What a scalable system means, meaning a system that can itself intelligent enough to scale up, scale down, depending upon the volume of data which is coming in, right? Meaning, if let's say today I have 10 lakh records, it should be able to handle. Let's say tomorrow, if I have 1 billion records, then it should also be able to handle, right? Then data governance. It's a very big topic what data governance is, but in small nutshell, how you govern your data, what kind of accesses you are providing, right? Real-time processing, very big challenge today, right? With the fast age world, we have Zomato, Swiggy, Uber, right? All of these apps are purely built on top of how you handle real-time data, guys, right? Then what are the tools that we uses as a data engineer? So for storage, we uses S3 bucket, DynamoDB, Redshift, Snowflake. For doing ETLs, we uses AWS Lambda, Glue, EMRs, Databricks, Snowflake. For orchestration, what do we use? Step functions, Airflow, right? For handling big data, what all techniques we have? Hadoop, Spark, PySpark, right? So, guys, all of this we gonna learn in our sessions going forward, right? Quickly moving on, we have touched upon what data engineering is. I want to also touch upon what AWS is. But before we begin understand what AWS is, let's first of all understand what cloud is, right? So the picture that you see here, this is not the cloud that we're gonna learn, right? The picture that you see here, this is the cloud we're gonna learn going forward. So what cloud means? A building, a place, a infrastructure which is very secured, and it's away from normal human reach. where you can store your data safely, securely, permanently with 24/7 data availability. This is what we say cloud is. Classic example of cloud that everyone must have used is Google Drive, right? So with Google Drive, you have to upload your information, and once uploaded over there, it is safe for eternity, right? Let's suppose you lost your laptop, mobile phone. No, it's fine. You just need your username and password and internet to access this information again, right? And you should be able to access it nowhere, no matter where you are sitting in the world right now, right? So how this information is stored? It is stored in the cloud itself, right? Now the question two is why this course is built on AWS itself, right? So if we look today, the major cloud providers in the market, we have AWS, Azure, Google, basically GCP. Azure is from Microsoft, GCP is from Google, then Alibaba, Salesforce Cloud, Oracle, right? Few other clouds as well. So if I look at the uses pattern of these clouds, today AWS leads the market in the uses patterns. Not only in the uses pattern, but if I look at the job postings as well, AWS is the one who has the maximum job posting across all, followed by Azure, followed by Google, and few other small clouds itself, right? So that's why this course is being designed on AWS to cater the maximum portion itself, right? Moving on, we understood a little bit of what cloud is. Then why AWS? What cloud computing is? Why do we really want to use cloud computing for, right? Why people are so crazy about cloud computing? So to understand all of this, again, I want to go through one example, right? So let's suppose we are planning a trip to a foreign country, and the trip is gonna be for 30 odd days, 1 month, give or take. And as part of your trip, you have plans to travel to multiple places within that country, and you decided to travel it through a car, right? You're gonna drive yourself that car, and you will be traveling it for 30 odd days using that car itself. So you have two options. Option number one is go in that country, buy a new car, buy the registration of that car, insurance, road tax, and number of things. Use that car for 1 month, and after you are done, the catch is you cannot take that car back to your home country. You have to leave that car over there itself, right? Case number two is there's a renting company in that country, so you can rent a car from there, and then they will take care of the insurance, license, and everything. You just have to pay for the number of days you are using their car itself, right? So let's say if you are that a traveler, which option would you prefer using? Option A, where you buy a car, or option B, where you rent a car? Anyone can unmute. You can type in chat. Just share your thoughts. Anyone, right? There's no right and wrong. Whatever you think is best for you, just let me know your thought process. Okay, if people are shy enough, either I have to see the chat. Okay, option B, two people are saying option B, rent a car, and right. How about others? Right, we have good number of people. Don't shy away, guys. Let's have a very bi-directional conversation. What do you think? Option A or option B?
Option B would be feasible, Aditya.
Correct. Correct. Very good. How about others?
Could you please repeat the question?
Yeah, so I was explaining about a scenario that you have to travel to a country. You will be staying over there for 30 days. You have two options. One is go over there, buy a car, pay for the insurance, pay for the road tax, take care of everything, travel the country with your car. But the catch is you cannot take the car back home. You have to keep left the car in that country itself. Option two is there is a renting company. You can rent a car from there and they will take care of insurance, road tax, and everything. And you have to pay only for the number of days you are using that car. So, guys, which option would you prefer as a traveler? Option A or option B?
For me,
For sure,
Option
option
B.
yeah, for sure, option B.
Same for sure. Option B.
Right. So, I'm getting a very big mandate on option number B, where everyone is saying let's rent a car. So, why you guys felt let's rent a car is a better option?
because of the duration for which we are going to stay there.
Mm-hmm. Okay. What else comes in your mind?
Because we
Means
don't need to take care of other things.
Yeah, it depends on
Correct.
the requirement.
Correct. Correct.
we
So,
should
what I
not, no
come.
need to maintain it. The company will take care of it completely. We can directly use it and we can fit it whenever we don't want it.
Correct. Right. So, your thought process is absolutely right, and that's the right thought process why people use cloud computing. Right. I'll give you a real example now. So when Netflix started back in 2005-6, Netflix was a movie rental company, right? I don't know how many of you have seen VCRs. VCRs, you know, act like a DVD, right? But it take more size. So basically, with the help of VCRs, you can view movie. It was very popular in 2003, 2004. So in US, people used to rent VCRs, or you can say in simple language, movies from Netflix stores. These are the actual store located in Manhattan, New York, and few other places. People go over there, their physical store, rent the movie, and they watch the movie and pay whatever the money is, right? Then then few years down the line, Netflix business is very good, but after 1 or 2 years, dot-com bubble happened, and what with that, everything has started moving to internet. Then with this internet wave, lot of companies, I would not say company, but kind of a freelancer or whatever, they started posting these movies and TV shows online free of cost over the internet. So people just have to go to a specific website. They can watch that content free of cost over there, but the quality was pathetic. Lot of ads and everything was there. Netflix also felt, okay, we are losing our market share. Not many people now coming to a physical store, renting these cassettes to watch movies, and they're shifting to internet. Let's do one thing. Let's also launch a solution which is which can run on internet, and then people can use internet to watch the movies, and we can charge for that itself, right? And that's how the Netflix online platform born in 2005, 6, 7. I don't know the exact year, but that's how they were born. So what they were doing is they were uploading their videos over the internet, and then they are allowing people to watch the movies. In an exchange, they were charging some money, right? Things were fine, but to maintain these movies, they have to maintain their own servers, right? Where they are uploading these movies, right? So, for example, in your Google Drive, you have 15 GB of free space. You can upload anything till 15 GB, right? Imagine Netflix is a movie rental platform. So, definitely they will be having loads and loads and loads of data. So, to maintain and store their data, they were maintaining their own servers, right? So, what is the big deal about this? It's simple. Buy a server, maintain server, upload data over there, expose this data to consumers, charge money. Why? What is the problem with that? The problem is these servers are nothing but hard disk, hard drives, right? Actual computers. And the problem with the computers are they got heat up so quickly, right? They need lot of maintenance. You need lot of infrastructure engineers only to install these server, maintain these server, right? And we know every year you need security upgrades. Every year you need security patches. 2 3 years your hard disk may start corrupting in, right? You need to replace these hard disks with new hard disk. Hard disks are very costly in nature if you talk about terabytes of data, right? So all in all, maintaining a server is not a joke. It needs lot of manpower, it needs lot of money, it needs lot of infrastructure. You need big buildings, you need cooling solutions, you need a number of things. So that was the problem Netflix was facing at that time, because the number of movies, the number of TV shows was getting bigger, and lot of people, they have a good audience, good customer base itself. So they were not able to fulfill the demand, they were not able to fulfill the data storage for themselves, right? Then at that exact time, AWS Cloud reached out to Netflix with a solution saying that, hey, let's use our solution. So you as a Netflix just upload your content to our platform, and we will take care of maintaining the server. We will take care of maintaining everything for you, right? So what you just need to do is upload your videos in our platform. That platform today is called S3 buckets in AWS, right? Upload your content to our platform and pay to us monthly or yearly or daily, whatever the agreement is, right? And you need not to take care of anything else. We will take care of anything. You focus on your own business, which is of making customer watch this content over the internet and charge for that service, right? That's your forte. Focus on that. We will take care of maintaining the infrastructure for you. And guys, that's where AWS never looked back. Today, AWS is the market giant in cloud services, and that's what cloud computing is all about today, right? So it's all about providing these kind of solutions where the company can quickly rent their servers, do bunch of things without worrying about who is gonna manage and maintain these servers, right? For example, there's a company called Pepsi, or there's a company called Nestle. There's a company called, let's say, Pfizer, right? These are market giants in their own niche. Their main strength is building drugs, building a Pepsi, right? Walmart main strength is retail. If they started spending a lot of time in maintaining infrastructure and service, they may lose their core principle, core value they provide. So that's where AWS or any cloud solution comes in, provide them support which they need to run their workload, to store data, to run the ETL jobs, to do machine learnings. All of these is basically being provided by the cloud computing, and that's why cloud computing is getting very popular day by day, right? And one of the important aspect is, let's say you want to do a POC, and in this POC you need a lot of big compute and servers, right? One option is go out there, buy these heavy servers, do your POC for 1 or 2 months, and let's suppose your POC by any chance does not make to production, then your server is waste, right? You may use it for some other work, but let's suppose there is no other work, then what are you gonna do with those servers? They are sitting just lying out there for you. On the other hand, you can go to AWS, you will do your work, do your POC, pay only for 1 or 2 months, and that's it, right? No need to pay anything extra for them. So, guys, this is few benefits I'm just quickly talking about cloud computing, and this is what we get from AWS itself. Now, quickly moving on, you know, what all topics we're gonna cover in our sessions. But even before that, I'll just take a quick pause and see if there is any query question coming in your mind, guys, so far.
Hello.
Yeah, please go ahead.
Yeah, I have a question. Like, what is the difference between the database and the cloud?
Okay, Databricks is a platform that help us quickly run big data load like Spark jobs. And then cloud is just a platform that provide us compute and resource, right? So Databricks is purely dedicated to running big data solutions. Cloud has more, how do I say, cloud has more features than what Databricks has to offer. So it can not only talk about big data, but cloud can provide servers, cloud can provide APIs, cloud can provide you storage and a number of things.
Okay, thank you.
Yeah. Okay. If there are no questions, guys, so the course is built in a way that we provide you real world knowledge of what data engineering is all about, right? So we are focusing on real world tools, applications, and with this, our focus mainly will be on AWS. And to build data engineering pipelines, we would be utilizing AWS, followed by few other popular tools that are lying there in the market, right? For example, Databricks. We would be using Databricks for running big data jobs, learning PySpark, Spark itself, right? Snowflake for data warehousing, database solution. We would be doing data modeling, normalization, denormalization using Snowflake. And side by side, we will learn how Snowflake help us provide better ETLs. We would be learning Airflow to orchestrate our ETL pipelines, right? And then everything will be purely backed by AWS itself. If I have to show in details the major topics that we would be covering is SQL and Python, Spark, AWS topic like S3, Lambda, Kinesis, Redshift, streaming solutions like Kafka, right? ETLs, big data, Glue and Athena, right? Lot of AWS use cases and case studies. We would be doing all of this in our sessions going forward. I have a detailed list of topic. I'm gonna share this slide after the session itself. You can go through it. What all topics are getting covered as part of our sessions? What these topic entails, right? So if you don't have any questions so far, I would like to a quick demo I have prepared for you, like what you can expect in the course going forward. I'll just wait for 1 minute. If there is any question, I'll take it. If
I
not, then
have one question.
yeah, please go ahead.
Like, why we are learning AWS, not like Azure? Azure is a Microsoft product, and what I have seen now, like most of the companies prefer the Microsoft product.
Okay, good point. And you are absolutely right. Nowadays, Microsoft is preferred. But if I look today in the number of job postings on LinkedIn, Naukri, or whatever the major platforms are, AWS still leads the market. Not only job posting, leave aside job posting. If I look at the uses, right, the uses pattern, AWS still leads the market by a margin from Azure or any other cloud. So that's why we are learning this course on AWS. And if I go out there in companies, most of the companies still prefer AWS over Azure.
Okay, so later if we need, if I feel like I need to learn the Azure, so like only Azure platform need to learn. Apart from that, everything will be the same.
Absolutely right.
Concept.
Thank you so much for providing this comment, right? This is the exact crux of it, right? We need to understand what ETL is. We need to understand what big data computing is. We need to understand what cloud computing is, right? If we are able to understand these topics, it doesn't matter if you are using Excel, if you are using Informatica, if you are using AWS, or maybe 10 years down the line, a new tool will come in, right? These concepts gonna be there with us throughout this journey. The only thing that can change is our platform, but the concept, guys, gonna be same, right? So for S3, we will be building a data lake. right? So data lake is a concept that you can do it on AWS. It's a concept that we can do on Azure. It's a concept we can do on Google Cloud as well. But to build a data lake, we would be utilizing S3 as our service.
Yeah, I have a question.
Yeah, please go ahead.
Yeah, what are the roles and responsibilities of a data engineer?
Okay. I try to summarize this here in terms of responsibilities. But if I have to give you a one word answer, is to build data pipelines or ETL pipelines. Now, how you build it, what is your data source, what is your target, this is something which can vary depending upon use case to use case, company to company, scenario to scenario. You would be building a batch pipeline wherein you are reading a data from a file, then storing it back to a target database. You may be in some other scenario handling a streaming pipeline where you're handling streaming data coming at fast speed and velocity, and you are processing and reading and writing at the very same time back to a target. Target can be a file storage system, S3, or it can again be a database.
What
And
all
to support,
opportunities do we? Yeah, yeah.
Mhm.
Go ahead.
Yeah, and to support this, you're gonna need infrastructure, lot of infrastructure. That also is a part of our data engineering responsibility. And to deploy all of this, we may need CI/CDs. We may need DevOps and as well. That's also some responsibility that data engineer play as well.
What all opportunities do we have once we are done with these codes in the market?
It's a very vast question. So I would say you would be able to apply or appear in interviews with AWS as the cloud and data engineering as a general requirement, right? Be it big data kind of a work, be it Snowflake kind of a data engineering profile, be it Airflow kind of a work which is required. And that's why, right, I am trying to use most of the popular tools which are there in the industry, and I try to bake them all in this course and give you back a solution that when you go out there in the market, you are covering most of the biggest, most of the most important tools out there in the market. So if you go out there, guys, search the job posting, see what are the major common tools that you are seeing in data engineering profiles, and see if these tools are the one which are highlighted over there or not.
So I have one more question.
Yeah, go ahead,
Yeah,
please.
yeah, yeah. So as a fresher, we are not getting any jobs for this data engineer, right? As if I want to start my career as a data engineer as a fresher, I'm not eligible, right?
Why not?
So I can see that most of the opportunities is for experienced candidates, like around 3+ or 4+ as a data engineer.
Hmm.
So I was currently working as a data analyst. I have 2 years of experience. So once I done with this course, was I eligible to get as a data engineer with 2 years of experience?
I don't see any challenge why you should not
But
appear or
the
get the data engineering interview itself. So data analyst and data engineering is a very close profile. It often overlaps. 50-60% of the time the profile overlaps. As a data engineer, what you need? SQL, Python,
yeah, yeah,
right?
hmm,
That is common
Python.
in analyst as well. PySpark, right? What else?
Hmm,
How you build ETL pipelines? And for
hmm,
that, we're gonna learn AWS, we're gonna learn Airflow, we're gonna learn Databricks, right? We're gonna learn Snowflake.
yeah.
Okay. Questions, guys?
Hello, Aditya. Can you hear me?
Yeah, I can hear you.
Okay, so I had one question regarding the project that is part of this course.
Mm-hmm.
Is like the topic or the subject or whatever the requirement for the live project, is it like predefined or like can you like throw some more light on it?
Can you elaborate your question a little bit? I'm just trying to understand the question in detail.
मतलब ऐसे पूछ रहा था कि जो अपना प्रोजेक्ट रहेगा एट द एंड ऑफ दिस कोर्स वो स्पेसिफिक कोई मतलब सर्विसेज को यूज करके विल ट्राई टू अकम्प्लिश दैट और वुड इट बी लाइक सॉर्ट ऑफ जेनरिक?
Very good question. Thanks for bringing this up. So, guys, before I answer this question, um, the topics, it's a very detailed topic list that we're gonna cover. That's the curriculum that we're gonna follow, right? So, if you see, we have a curriculum of near about 45 days. These are the topics that we would be covering throughout our curriculum itself. Now, coming back to the projects, right? I have at least 3 to 4 projects that I would be utilizing using combination of services or tools. Right? I could only build using AWS. I could only build using Snowflake, but no, I don't know what kind of job profile you will go into in future, what kind of requirements your interview needs. Therefore, depending upon the major market requirements, we built 3 to 4 projects that caters to multiple tools out there. Right. So I have a project that solely talks about. Okay, let me do one thing. Let me open my projects itself so that you have a better idea. I'll show you the different versions and everything. Sorry. Whew. Okay. 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 One of the project that we're gonna build is, guys, is this. We will be building a automated data lake solution, and to build this, we would be utilizing AWS services like S3, Glue, Lambda, Crawler, CloudWatch, SNS, few other popular services. For the similar project, I have one version built with Snowflake as the integration. Similarly, another version of the project I am building using Airflow plus AWS plus Snowflake. Another version of the project I have with PySpark plus Databricks plus S3. Right, I'll show you that another example. So this is one of the project I have. Here we would be utilizing clickstream data, building a lot of ETLs analytics on top of it. And to do this, we are using PySpark plus Databricks plus S3, right? So the the projects gonna be the real world projects that I can find over the internet. I cannot actually go tell the proprietary solution, otherwise we're gonna end up in IP problems. But whatever is available out there in open domain, those projects I'm collecting, we're gonna discuss all of those projects. These are real world projects, and you can then modify these projects as per your current work. For example, you work for a banking domain and we are discussing, let's say, e-commerce project. You cannot tell, hey, I worked on e-commerce project. Then the interviewer can question you back, you are working in a banking domain, how come you are doing an e-commerce project, right? So what best you can do is use your collective intelligence, see how you can relate this project to a banking domain project, and then explain it while you appear in your interviews, right? I hope this is close to what you are expecting as an answer. Do you have any follow-up questions?
uh, yeah, so like from what I understood by just said, yeah, like we won't be having like a definite problem statement before starting the project, right?
we'll like explore and try to integrate as many services as we can.
No, no, no. We're gonna be having definite problem statements before we begin our pro- classes itself. To build that project, we're gonna start from one service at a time, right? For example, if you see this, it's a definite problem statement I have. The problem statement is we're gonna build a data lake solution that follows Mendelian architecture, silver, bronze, and gold layer. So how do you make sure that you are handling batch streaming and everything, and keep your data lake updated with the latest information, and it is getting exposed to downstream system? Build a solution around that. So we already have a problem statement in mind. How do we achieve it? So we're gonna do it through multiple ways, right? One way is this. I'm gonna show ways through Databricks. I'm gonna show you ways through Snowflakes as well. Now you may question, why multiple ways? So to answer a problem like this, there cannot only be one definite answer. There are various versions, and each company uses their own version. Why? Because what all resources available for them. So if a company is very heavy on Snowflake, they will not use Databricks. On the other side, if a company is very heavy, meaning if they're using a lot of Databricks, they may not go to Snowflake, right? So that's why we have the solution built with different versions of the same solutions with different technologies used.
Yeah, understood. Thank you. Thank you so much for answering.
No problem.
I had another question, if you don't
Yeah.
mind, can I
Yeah.
ask that
Please,
as
please go ahead.
well? Yeah, so y- as a part of this course, we'll be covering will be covering AWS Lambda as well, correct?
Correct.
So AWS Lambda will just like act as a what you can say it give, as you know, it gives a runtime for our Python code. So would we be focusing more on the Python, like coding that is done in Python, or using AWS Lambda as a service?
Very good question. My intent is to build data engineering pipelines. Right now, Lambda is one infrastructure tool that you can use to build pipeline. I would be using for the same kind of work Glue. I would be using EMR as well for the similar kind of work, right? And by turns, for Lambda we need Python, for Glue we need PySpark, for EMR we need PySpark. So we will be focusing on these technologies as well. But my main intention would be building data pipelines, not on learning Python, not on learning SQL, right? Because if that is the main intent to come here, then I would recommend that there are better courses out there in the market, right? If you go to Udemy or YouTube as well, free course available where you can learn Python and SQL, and there are better tutors than me, I can guarantee, and I can refer to those playlists as well. Go out there, learn those topics, and then come back if required.
Okay, understood. And thanks for answering with so much honesty, because I have like used Python and Redshift, sorry, Lambda and Redshift quite extensively, but yeah, the coding part is where I'm lacking.
Okay,
So whatever material, if you could provide, that would be like super helpful.
sure.
Thanks. Thank you.
Okay, any queries, guys?
Any questions from anyone? Yash and Ashur, Vinay, Ravi, Poonam, Vinay, Kumar.
Hey, hi, Aditya.
Hey.
Uh, yeah, I just have one quick question.
Mm-hmm,
Currently, I'm working on real-time data, and my
mm-hmm,
company is purely startup company. So we have to build everything from scratch. And I'm
mm-hmm.
new in data engineering field. I just joined before 1 month ago. So if I get any problem in real-time process, so uh, in future, if I need your help, so you can suggest me, right?
Yeah,
Some
we can
points like
definitely.
you
Yeah,
can, yes. Okay, no problem. And you are going to cover one project in the last, right?
Yeah, I am gonna cover a couple of, not one. So
Okay.
one would be a data lake project using Medallion architecture. One project would be using PySpark plus Databricks, where we would be utilizing e-commerce clickstream data. Then one project using Airflow plus Snowflake, where we will be doing data modeling, data warehousing. Right. So we would be covering not one, multiple projects.
Okay. No problem. And what is the exact difference between S3 and Athena?
S3 is a data storage. Athena is a data query tool.
Okay. Yes. Means we cannot store any kind of data on Athena.
Yeah, you cannot.
Okay. Okay. Thank you.
Okay, thank you.
Any other question from anyone? Ravi?
Ganesh, I'm good.
Vinay Kumar?
Yeah, I'm good.
Charan? Yeah, Vinay Mudraj.
Yeah, I don't have any questions.
And Yaju?
No questions from me.
Okay, then if you don't have any questions, then we can leave for now. And I'll update you about the session timings, the regular class timings and everything by tomorrow. I'll give you a call one by one tomorrow.
Okay, thanks everyone. Thank you.
Okay, Aditya, thanks for your time.
Bye.
Thank you.